Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This presentation illustrates the installation of ROS2 on Raspberry Pi hardware. This tutorial provides introductory guidance on the installation of a robot operating system, ROS2, on a Raspberry Pi single board computer. The Robot Operating System, or ROS, is a set of software libraries and tools for building robot applications. From drivers and state-of-the-art algorithms to powerful developer tools, ROS has the open source tools to simplify development of robotic solutions. The designation for the current robot operating system is ROS2. This tutorial uses a Raspberry Pi 3 Model B single board microcomputer that is operating under Ubuntu 22.04.2 long-term support, LTS. There is a 64-bit version of this operating system that is well suited for the Raspberry Pi single board computer, which has the Broadcom BCM2837 quad-core system on a chip. The acronym for the architecture of this version is ARM64 or AR64. Raspberry Pi 3 will run either 32-bit or 64-bit operating systems. For this demonstration, the chosen version of the operating system is the 64-bit desktop. Our preference, since we plan to use Ubuntu, is to leverage the 64-bit architecture with the desktop version of Ubuntu Jammy Jellyfish. In this short tutorial, the following topics will be covered: system setup, installation, and validation. A very short list of ROS distributions is summarized on this page. A ROS distribution, or distro, is a versioned set of ROS packages. The annual release date for a new ROS distribution is May 23rd. The current release is Iron Irvine. This tutorial uses the current release for demonstration purposes. After the release of a distribution, also known as general availability or GA, changes are limited to bug fixes and non-breaking improvements for the core packages. Maintainers of packages try to avoid breaking changes to the fullest extent that is practical. Discussions on ROS2 roadmap and governance are beyond the scope of this elementary tutorial. The Raspberry Pi 3 Model B is the earliest model of the third generation single board Raspberry Pi computer family. It uses the Broadcom BCM2837 Cortex A53 quad-core chip. While the CPU is 64-bit, the RAM is limited to 1 GB LPDDR2 only. There is a Model B board too with improved dual band wireless LAN, Bluetooth, faster Ethernet, and Power over Ethernet PoE capability. The Raspberry Pi 3 family ceased production in January 2023. Comments on supply chain issues regarding the availability of Raspberry Pi single board computers are beyond the scope of this tutorial. This video demonstrates the use of the older model B board. All exercises are performed in headless mode over a 1 gigabit Ethernet connection. Unfortunately, the USB 2.0 drivers limit the throughput at 30 megabits per second. The Raspberry Pi 3 Model B is the earliest model of the third generation single board Raspberry Pi computer family. It uses the Broadcom BCM 2837 Cortex A53 quad-core chip. While the CPU is 64-bit, the RAM is limited to 1 gigabyte LPDDR2 only. There is a Model B board too with improved dual band wireless LAN, Bluetooth, faster Ethernet, and Power over Ethernet PoE capability. The Raspberry Pi 3 family ceased production in January 2023. Comments on supply chain issues regarding the availability of Raspberry Pi single board computers are beyond the scope of this tutorial. This video demonstrates the use of the older model B board. All exercises are performed in headless mode over a 1 gigabit Ethernet connection. Unfortunately, the USB 2.0 drivers limit the throughput at 30 megabits per second. The two key steps to prepare for the installation of ROS are set locale and enable required repositories. An optional step to install development tools will be covered in a future tutorial. Locales customize programs for a specific language and country. Naturally, the program must be capable of using the locales feature. ROS, being popular all over the world, leverages the locale feature to accommodate the regional requirements for language and country to the extent practical. While it is possible to build and install ROS from source, it is beyond the scope of this tutorial since binaries are readily available for the hardware and operating system combination used in this tutorial. Using binaries is an excellent choice to start using ROS2 quickly. The locale settings for ROS2 Iron Irvine are shown on this slide. Lang provides default values for LC underbar asterisk variables that have not been explicitly set. LC underbar address is for the address format, country first or last, and where the zip code is placed. LC underbar all overrides individual LC underbar asterisk settings. LC underbar all is set, then none of the below values will have any effect. LC underbar collate how strings file names are alphabetically sorted. LC underbar C type is for how characters are classified as numbers, letters, etc. This determines things like how characters are converted between upper and lower case. LC underbar identification is for metadata about the locale information. LC underbar measurement is for units of measurement that are used: feet, meters, pounds, kilos, etc. LC underbar messages is for the language that should be used for system messages. LC underbar monetary is for the currency that will be used, its name and its symbol. LC underbar name is the representation of images, surname first or last, etc. LC underbar numeric is for the format of numbers. For example, in many countries, a period is used as a decimal separator, while other countries use a comma. LC underbar paper is for paper sizes, for example, 11 by 17 or A4. LC underbar response determines how responses such as yes or no appear in the local language. LC underbar telephone is for the telephone number format. LC underbar time is for time and date format. It's used to get the 24-hour clock in some programs. The vast majority of the software in the Ubuntu Software Center comes from the Universe repository. These packages are either automatically imported from the latest version of Debian or uploaded and maintained by the Ubuntu community. ROS2 is no exception. There is active community support for issues as appropriate, even though Canonical does not provide official support for the packages in the Universe repository. Jammy Jellyfish, like all Ubuntu long-term support, LTS, is supported for 5 years, but Ubuntu is not on the hook for official support of the packages in the Universe repository. It is always prudent to stay in touch with the ROS2 community to be apprised of updates and upgrades. upgrade the APT repository caches, upgrade the platform as a prudent measure to ensure new packages are using the latest compatible versions. There are two variations for the installation of ROS2. One can perform either the desktop install or the base install. The desktop install is highly recommended because in addition to the base ROS packages, it includes supporting utilities like RViz for visualization and demonstrations and tutorials. The base install is essentially a bare bones installation of ROS, being limited to communication libraries, message packages, and command line tools. No graphical user interface or GUI tools are installed when the base install is selected. The file type extension listed on the slide is .bash. This file type extension is for Debian and Ubuntu platforms. Other platforms may use a different file type extension. Source is a shell built in Bash or other popular shells that are used in Linux and Unix operating systems. The source command reads and executes commands from the file specified as its argument in the current shell environment. In this context, the file setup.bash loads functions, variables, and configuration files to support ROS operations. This demonstration is a very simple example to illustrate the publish-subscribe model in ROS2. The node on the left, talker, publishes a message with a specific topic, hello world. The node on the right, listener, subscribes to all messages with a specific topic, hello world. The publishing node outputs the message every second in this demonstration and qualifies it with a specific identifier. The listener node receives the message with the specific topic and displays the identifier for demonstration purposes. This demonstration illustrates the use of nodes and topics that are central to ROS2. The nodes in this example are talker and listener. The topic in this example is hello world, the message published by the talker and received by the listener node. The demonstration uses two nodes and one topic. One node publishes the topic, and the other node listens for that topic. The topic itself is a simple message in the style of a hello world string, but each publication is assigned an unique identifier. Here are the 3 steps to start a very simple talker node to publish a topic. First, launch a new terminal window. Second, source the setup script in the new terminal window. And finally, third, run the talker node to publish the topic. In this specific example, the node is written in C++ language. The 3 parameters of the ROS2 command are the first parameter run to perform the publication of the message topic. The second parameter demo underbar nodes is the name of the package, and the third parameter talker is the name of the publisher. After the talker starts running, it echoes nominal diagnostic information in the terminal window for current demonstration purposes. Since the talker node window is printing output while it is running for demonstration purposes only, launch another terminal window to run the listener node. Here are the 3 steps to start a very simple listener node to subscribe to a topic. First, launch a new terminal window. Second, source the setup script in the new terminal window. And finally, third, run the listener node to subscribe to the topic. In this specific example, the listener node is written in Python language. The purpose is to demonstrate that ROS2 is language agnostic with respect to writing code for the nodes. The 3 parameters of the ROS2 command are: the first parameter, run, to perform the publication of the message topic. The second parameter, demo underbar nodes, is the name of the package. And the third parameter, listener, is the name of the subscriber node. After the listener node starts running, it echoes nominal diagnostic information in the terminal window for current demonstration purposes. A node may publish data to any number of topics. A node may subscribe to any number of topics. Nodes and topics provide the basic topology for ROS2 data exchange. A node can publish and subscribe to any number of topics. In other words, topics are not limited to point. Topics can be one to many to one, or many to many. There are very simple commands to obtain more information on nodes and topics in use in a particular configuration. These commands will be illustrated in a future tutorial. For this simple demonstration, a topic is tagged with a unique identifier for each message. Each unique identifier printed by the talker node is echoed by the listener node. All topics from the talker node are processed by the listener node. That's all, folks. Please provide feedback in any which way you can. Presentation was prepared with assistance as noted on the slide. My apologies if I have unintentionally or inadvertently omitted anyone or any resource from recognition. A very big thank you to y'all. Come back to the channel soon.